Okay, let's try this again. I'm not much of a good vlogger, given as I'm not keeping up to date, and Christmas got in the way. Then I started work back on this project, and after quite a bit of coding, suddenly made a bit of a breakthrough, and then another breakthrough, and then pretty soon I'd done all the interesting stuff I'd been saving for this whole vlog, which was kind of like the CNC foam cutting that I'm just going to try and show you before I forget how it all worked, because it's now done. So as you can see, this was an ear that I cut, I think it was early last week, really, when I first started getting it working. This is using some more luxury foam that I'd ordered from Any Foam, and it didn't cut so well. It might be great for sitting on and making sofas out of, but in terms of machining, it didn't do half as well as this sort of like slightly stiffer and cheaper looking material that I could get from around the corner in about half meter squares, 1 inch thick. That's the thing. Oh yeah, the other thing is that the milling cutter that I'm using, which is like an old Dremel, can't do the last 2 millimeters against the bed. So I'm sticking these things down with double-sided sticky tape onto the bed, and then milling as much as I can with the router. And there's a sort of a screw sticking out the bottom, which doesn't get 2 millimeters, and so you wind up with these sort of layers. And I was trying to see whether you should stick them together and then trim off the layers with the scissors afterwards, but I decided that was wrong. You should just trim it up beforehand and sort of put up with the little gaps. Here's an example of the milling as it was proceeding on the sort of blue stuff that was cheaper and better at milling. And every so often I'd do a piece that would break all the software and I have to spend another couple of hours rewriting it. This one was hard because the piece comes underneath and has to cut round over the top and then go back in, and that kind of more complexity I wasn't handling in the original software, but made some changes. It ran twice as slow, took twice as long to calculate, but it doesn't really matter because there's only doing one job. I was going to show you a bit before we go further. I should just show you what was going on in the Blender code. So we'll stop that. Right, so here we are in Blender. This is the hopefully it's showing up. This is the piece that I'm trying to make, and if we select it, it's got modifiers such as the mirror modifier, which then actually makes it solid. It's much happier for things. And I've designed a series of these planes. So I think that's a plane which is got a solidifier on it, so it's basically a rectangle. I've drawn it wireframe so we can see through it. A rectangle, and then add a solidify modifier to add 1 inch thickness because that's the size of the planes, and then it's more easy to sort of position and move these around. It's one of the weaknesses of a design tool like Blender is it's not CAD. You can't put measurements in and expect things to be in their right place. You have to kind of do things one by one and keep close eye on what's going on. Now, the modifier is, so the first thing is that this geometry is quite complex. So what I've done is I've broken it into 3 parts. So the first thing I did is I took off the ears with a where's the ear trim? Oh, it's probably under me. Are you going to see that? Let's maybe move that out the way. No, it doesn't show up. Okay. Maybe move that one wider. Okay, you might see it. Okay, there's the ear trim. I'm not going to move myself around. It takes forever to set this up. And we can turn that on, and we'll do the ear trim, that one first. Yeah. So this is if you're working on the ear alone, which was what you saw before, a bunch of layers after rotating it around. And this is cutting it off. And then similarly, we've got the cheek, which was another slab, turn it into a simpler part that's going to be cut in that direction, or we can take the difference and remove it. So now we've got a much simpler shape that we can do slice by slice in this vertical plane. And so the first vertical plane is like so, and there you have it. And then These are 3 pieces I can mill individually as long as there's not too much of an undercut. That one here, it's way too small to actually fit the tool piece. But if I add in another thing to subtract from it, will be here. We can, is that going to be, yeah. Oh, well. That one. Phooey. 1 second. Pause. All right. Yeah. There's several of these different solvers for it. But yeah. So there it is. Turn it on. Turn it off. And so once you've divided up into that piece there, it's actually small enough. And that's not getting the face right. But let's sort of go back to that. See, we've got these 3 different solvers. The final one being this manifold one, which is the extremely accurate one. That was it kind of what started this all off. I'll give a link to that one as well, because this was a computational solid geometry tool that I first discovered when someone put it into Godot. And so that was my original workflow, was going from Blender to Godot to do this slicing and geometry thing, and now exporting into FreeCAD. And FreeCAD, I've written loads of Python modules for doing the toolpaths because it's kind of CAD. But what I've done is I've ported all that Python stuff since this divider and the intersector thing is now in Blender. I can move it out of Godot, and I know how to position things in Blender. And then I took all the Python code from FreeCAD into a big Python module in Blender to do all my milling. I was going to sort of show you what goes on here. I actually don't have the module loaded up in here, but I do have the output. So what would happen is that you would take that piece there, and then you'd call something which would place it down. Let's see. Yeah. Is that working? You have to do view and frame selected. Yeah. Okay. It would place it down into, let's make it a bit bigger, into a position where the larger face was on the bottom. There we see it. And it's sort of, our tool is going to be able to undercut and cut upwards nicely. Then what happens is it went into several different things. Yeah, it would do the slicing, which is my special slicing toolpath for a disc that was 38 millimeters in diameter. So that's kind of offset, and only about 2 millimeters tall. So that's why this has undercuts in it. And after the slicing, you would then pick paths going up. So usually you'd pick a point, every 5 millimeters around this edge, and then draw a path up by picking the next point closest on the next layer up, next point closest on the next layer up, and producing a set of tool paths that kind of look like this, right? And the problem, so there the tool would sort of run along here. You'll see this in the video. Now the problem with that is that the tool would, if you just followed one of these and it was the first time, it would go in and get buried and sort of tear up the foam on the very first go. So you need to sort of nibble at it, and that's where I used a bunch of techniques that I made in the adaptive clearing algorithm that I invented, whatever, back in about 2004. That's good for roughing, and I used that technique to model the stock so that I would just go in a certain distance and then scoop out, and then go in a certain more distance and scoop out. And if we see that, yeah, we can see these are the actual limits of the pieces. Is it would go in there and scoop up, and then the next piece would go in there and scoop up a bit more, and the next piece would go, and it would keep changing the order around as it was. It would jump here and then jump here, and sort of nibble away at this. And then these annoying little spikes here were really awkward, because if I just moved in and then just scooped up, it would just take off this overhang. So I then had to keep track of where all the overhangs were and move out far enough to get free of them. So yeah, it was kind of, this is done in piece by piece. And then, and then when you come down to it, you have to come down on the outside and go under it and follow up. So many special cases that were happening. But yeah, it worked in the end. The Blender stuff isn't so interesting. I'll give a link to it, but only I can use it probably at the moment. If anyone else wants to use it, they'll have to. Well, there's no point in me making it in a state for other people to use unless there's anyone who actually wants to use it and has the means. But we could start from there. But the right place would be to get this into this Blender Cam program, or as I think it was called. Let me see what it was called. It's called FabX, I think. I'll put a link in. I'll put a link in the notes about it. Where is it? Okay, yeah, I'll put a link in the notes about it. All right, but let's be done with the Blender and bring back the pictures. So yeah, there is milled, and once this thing was going, it would take between 3 and 7 minutes to do one of these pieces. The file would print out and give me the dimensions in millimeters, and I would just sort of like cut it with a pair of scissors, because 1 mil thick foam is the perfect thickness for cutting easily. I tried to do 2 mil thick foam originally. That's really difficult to cut with scissors or any way in a straight line, and also then the geometry on the side gets really complex, and it's just the saving of doing a double height one isn't worth it compared to just doing smaller layers and just gluing them together by a long way, as I discovered the hard way. I mean, I did try. And then here we go. Here's in progress. It's starting to look pretty nice, you know. And these layers, they're going to be covered up with the fur when we get to it. And there it is, all sort of glued together. I'm 3D printing the little 3-cornered tips, because that really is too fine to do in foam anyway. These bits here, I've discovered I need to strengthen a little bit with probably a piece of milk carton, so it doesn't flop over when the foam's on it. And there it is. But kind of fits on the old duct tape dummy. Oh yeah, things, as I said, things are racing ahead. We're already cutting the foam, and I mean, cutting the fur, which I should report on how I did that, because that's also another Blender plugin, and I really like sewing, so I just can't stop myself from doing that, particularly when I'm in a kind of a bit sad. So I spent all day yesterday sewing this together, and it's really nice. Here's some foam cutting. You can sort of see this is like before it's snarling it a bit because it's cutting too much, and it's this more difficult, less cuttable foam, but you're getting the picture. This one's much cleaner. You see, that's even, the cuts are perfect, and there's a little divot at the top to try and like take off the little pieces that get left on top. But yeah, I was very happy with this once it was going, and I guess that's probably it for the recording. Yeah, what else is there to say? Oh goodness, I've already gone on for too long. Anyway, right, bye folks. I'll talk to you about the fur, which is much nicer. But this was kind of like the breakthrough, making this out of foam. But if you are 3D printing your base models, which I'm not, but if you're 3D printing your base models, the same fur technique can work, because you will have a Blender representation of the model, which you can design the fur cuts on. This one here, I have a Blender representation of the model because that's what I've cut. Hopefully, foam's kind of nice, more cuddly, even if I've ruined it all by having that mane, which is definitely not cuddly. But yeah, see you later.